So we're going to hear from this wonderful person here. His name is Fred. He's been with Blue Stamp before. He's worked at Blue Stamp. He is awesome and amazing and knows kind of what you are building.
Weren't you involved in Blue Stamp at one point? All right.
Yeah. So he's very familiar with Blue Stamp and what we do here. Now he is a mechanical engineer who works on building drones and a startup that builds drones.
Yeah.
So he's going to talk to us about that and engineering in general. Please make it lively. We love to answer your questions, so please feel free to ask questions. Make it a conversation more than just us talking at you. So yeah, we'll get started in just a second as he gets connected.
All right. So you're a little test.
We can actually go straight into. Do you have HDMI?
How many of you are excited about drones? Drones and drone tech? Yeah, that's a lot of hands. You can see kind of sort of interested. That's cool. Learn some things about it. How many of you are interested in mechanical engineering? Building physical things. Yeah.
Throw it here.
How about startups?
Awesome.
Look at that. All these topics. Got a whole bunch of topics going on right now.
Cool. Awesome. All right. Well, Sam, thank you. I assume the projector will go on. Maybe it needs to be turned on. I don't have too much to show you guys, but maybe we'll get into some things. I find it's more fun to kind of go where this conversation is most interesting to all of you. Robin did not lie when he said you guys had a huge group this year. This is definitely the biggest cohort I have seen. How many of you guys are freshmen? Couple. Okay. Anyone in middle school? Yeah, nice. Overachievers. Sophomores? Juniors? Okay, you guys are in that sweet spot, starting to think about colleges. What about seniors? All right, you guys already know where you're going. You excited? Yeah. Of those guys that are seniors, with your hands in the air, keep them in the air. Hold on. Put them up.
Wait, rising seniors.
Rising seniors. Okay, good point. So you guys don't know where you're going yet. That's true. I should have think about that. Okay. Anyone who's graduated, actually?
Sahas.
Nice. Do you know where you're going? You're going to be in an engineering program? You're considering it?
Definitely strong on there. I definitely want to go to STEM.
Yeah, cool. Well, anything STEM, whatever. I mean, in all honesty, as long as you're going to college and doing something, or even if you're not in this day and age, you don't need to, obviously, as we've seen. Personally, I recommend it. Personally, I recommend doing something engineering related, but that's my personal interest because I love math, I love science, and more than anything, I love applying them into solving real-world problems. There's no clear-cut path as to how you get there, though. To be perfectly honest with all of you, this is actually fun and exciting for me. Today is my last day as a mechanical engineer.
Wow.
So yes, I'm actually leaving my job today. I have to go back and sign some paperwork and get out of there. And I will be actually going back to school myself next year to do a graduate program. So to give you guys my brief background really quickly, I grew up somewhat locally, about a couple hours south of here, and did not know what I wanted to do. I really love math and science, but it's very difficult to know what you want to do with that, especially when you jump into these big college applications and they're saying you got to choose a major now and know before you've really had the opportunity to experience it, which is why a program like Blue Stamp is such a fantastic opportunity, and it's something that I wish I had had. And it's why I got involved with the program after I graduated college. So I graduated high school. I actually took a year off, went and lived in Belgium for a year, had a wonderful opportunity as an exchange student, getting to see the world a little bit and take some time to even more figure out what it is that I wanted to do. Eventually landed on doing an undeclared engineering program at UC Berkeley. It took me 2 years then to figure out that mechanical was what I was interested in, at least at the time, and I minored in industrial engineering and operations research. Does anyone know what industrial engineering is?
It's just like the kind of like big corporate type of engineering.
Yeah, you're getting there. Yeah, so you can think of it more as systems level engineering. So if you think about an airport or a hospital and how they function and efficiencies and network flows, today's day and age, you can think of industrial engineering primarily as the big word around here would be data science. machine learning, all of those algorithms, those kind of embed themselves into either a full-on computer software, computer science program, or into an industrial engineering and operations research program. So I minored in industrial. After I graduated, one of my first jobs was actually doing Sam's job, working as a director for Blue Stamp, because I met up with Robin, was very interested in the program, and he sold me on the fact, and I was really intrigued that this was an opportunity I wish I'd had. You guys are getting a wonderful chance to delve into many different kinds of engineering, whether it's mechanical, electrical, software, hopefully maybe all of them together with your projects. Gives you an idea, gets you a taste of what you like, what you enjoy, and what you think you might want to go and study when you get into college. Or not, and do something else. It's totally up to you. But having that experience helps give you some background and guide those decisions. Once I settled on mechanical and industrial, I spent 2 years then doing a lot of calculus. Probably a lot of you are already doing calculus. You're going to have 4 or 5 more years of that, so don't worry, it gets even better. It's enjoyable stuff. And then after doing some Blue Stamp stuff, I worked as the lead instructor for the San Francisco program. And that was a wonderful experience as well before I left and went to a design consultancy called Frog. How many have heard of, anyone heard of Frog? Anyone heard of IDEO? Anyone? A couple hands, very few. I like to think of, there's kind of, in my experience, there's 3 main types of jobs you can kind of get out in the world. One of them's a startup. That's what I do now. And you could be a co-founder, you could be someone who gets in early and there's only 10 people, 20 people when I started at Matternet, or you could go in and there's, 200 people. That's still a startup in this day and age. Then there's big corporations, Apple, Facebook, huge companies, and there's consultancies. So my first role was actually as a mechanical engineer in a consultancy. Let's see if I can pull up Frog's website right now to give you guys an idea of some of the stuff that we actually worked on. Well, that's not the right Frog. Let's try this again. Backing up a little bit, we'll just let this play in the background. How many of you guys are interested in mechanical engineering? Anybody? They know that's kind of what they think they want to do? Okay, this side is very cool. I'll stay over here. You guys can take a nap. Mechanical engineering is a wonderful thing if you love being hands-on, especially. If you really like tinkering with tools, playing with Legos, which I'm sure 99% of you did at one point in your lives, it's kind of the evolution of that as an adult. We sit there, we think of a problem, we test a hypothesis, we do a lot of CAD, and then we eventually go and we prototype and we iterate, and then we manufacture and produce a lot of these products that you guys see and hold and use in your everyday lives. And that could be everything from cell phones to cars to anything, but it's much more in that physical realm. So at Frog, a lot of the projects we work on are healthcare initiatives. So I spent most of my time there actually working with Pfizer, designing products that would be used to kind of, they wanted to jump into preventative medicine. So we were working on air filtration and masks for China and air sensors. We were working on backpacks that could be used to weigh elderly and also get their hydration levels, because a big thing is dehydration when you become older. A lot of it is aimed at, a lot of those products were aimed at figuring out ways to keep people healthy rather than send them to doctors and get medications. So I spent a year at Frog, and then afterwards I left, because the one thing about consultancies, also, I'm talking really fast and just throwing a lot of stuff at you guys. If you guys have questions, throw your hand in the air. I'd love to actually answer your questions than just stand up here and ramble. With that being said, does anyone have a question right now? No? Cool. I'll keep rambling. I left and went to Matternet. Working in design consultancy is fun in some aspects, but you spend 99% of your time thinking of these very creative solutions, building out a few of them, testing some of them, and then you hand it off to the client and you never see it again. And 5 years down the road, they come out with a product that looks nothing like what you told them to build. Design consulting is all about just generating a lot of creative solutions and then kind of passing it off. So the reason I left and went to a startup to go to Matternet is ownership. When you work at a company as small as Matternet when I started, which was 20 people, we're now at about 70, you have an opportunity to do everything. You're not just thinking of the solutions. It was me and 2 mechanical engineers when I started. So we already had a drone that looked very similar to this. This is like a version 10. It'd be like comparing an iPhone 4 to an iPhone 10. When I started, we were at the iPhone 7. Now we're at the iPhone 10. So there are, about once a year you have to revamp and take in new technologies and add in a bunch of different sensors and kind of adapt your product. So I did a lot of work on the vehicle side, and then my actual main project, let's see if I can find it here. Play a short little clip for you guys. I doubt you guys are going to be able to see this, hear it too well, but I'll let this go. So this station that you see in the background, I built myself entirely from the ground up. There was no other engineers working on it. Well, I can't say that actually. There were no other mechanical engineers working on it. I worked with one other electrical engineer and one other software engineer. So it's very much so a collaborative project. But everything from the fairings that you see here to mechanical actuation inside. One thing, I think there was actually a short clip where you can see it. We actually use a robotic arm to do all the movement of taking the payloads and putting them into bays or delivering them to customers, and also taking the batteries from the vehicle and putting them into charging bays. So I did all the programming on the robot. You don't get that experience when you go and work for a large company. You might be the guy who works on this door. The classic example is if you go to Apple, you'll be the guy who designs the button on the side of the phone. When you go and work at a startup, you get to do everything. This is a really cool project. This actually took about a year. It lasted from about September of 2016 to the following summer. Since then, we've been iterating rapidly upon this. The station that we have now, that we're finally about to push out the door, looks nothing like this. So actually, we've done a whole new redesign. We ended up putting a massive hangar that goes up above the drone so that we can actually store these things outside, and also raises it out of the reach of any potential passerbys. So that's been a project that I've been working on now with a team of 10, 4 of which are mechanical engineers. So the complexity of the project that we're working on has grown immensely. And it's cool that hopefully in the next month or two, we're going to be able to actually release these to the public and start using them. a massive thing with our particular industry is the regulations involved with it. So currently in the United States, we are the only company that has permission to fly over normal citizens such as yourself. There are about 10 other waivers out there for commercial companies to do certain operations within the United States, but most of them range from kind of field testing out in remote areas, doing things like looking at power lines, looking at building construction sites to track progress. Agriculture uses a lot of it. We're the only company that actually flies in urban areas, and the reason behind that is our application is focused on healthcare networks, so we fly in between hospitals. We deliver blood samples from a laboratory to a primary hospital where it actually gets analyzed. So we currently operate in North Carolina. We're about to start operations in San Diego, probably soon nearby here with Stanford Hospital. And then we also have a big network internationally in Switzerland and a few other countries getting added on this year. So that's kind of what I've been working on. It's messy, yes.
What happens if it rains?
What happens if it rains? What do you think?
I don't know.
Do you think of, who thinks this? So in our current, is this a?
As a current, yeah. But you can say those.
I'm glad I asked.
Feel free to erase them.
To quickly answer the question, well, I want to see what you guys think. What happens if it rains? Are you referring to the drone, station, all of it? Do you think we operate in the rain? Raise your hands. The answer is yes. Now, that's why if you look at this station, there was a shot on the top and it showed there was a couple mechanisms that actually lock the vehicle to the top of this station so it doesn't move. Those aren't waterproof. There's big holes to make that actuation happen. So this particular station would not operate in the rain. That's not realistic because the reality is we have to design a product that can last for 5 years in any environment, whether it's snow in Switzerland or intense heat and humidity in North Carolina. You have to build a product that can withstand a lot of different environmental implications. That's why where this took me, myself, less than a year to design, the station that we're getting ready to release to the public took 2 years and a team of 10 to design. So there's a lot more effort that goes into making sure that every little hole is sealed, and that's just the station. The same thing exists for the drone. And you have to think about what are your implications, wind speed. We have to factor in, so there's a whole software backend that actually our network has to run off of. And normally, if, say this drone, it can fly at about 20 meters per second, has a range of about 25 kilometers. That's one way because we have to go one way, and if we can't land, we have to be able to come back, so it's actually closer to 50. But say you're doing 25 kilometers and you're going to get close to landing, but the wind speed's actually going against you, we have to factor that in and realize that, well, maybe we can't actually make that distance. So there's a whole lot of, you always have to consider the environmental applications as well. There's a few other companies, I'm sure you guys have heard of them, that are doing stuff in the drone space. Who can name a few? Anyone? Amazon. Yeah, they actually just launched a really cool new drone. Our CEO just actually made a public statement today on the news about it as well. He was on a television show. You guys can look that up. The reason we're light years ahead of Amazon is they just released a new drone that's going to take years to actually regulate and certify. Who here knows about the Boeing MAX 8 plane? Anyone? Couple people? Long story short, the MAX 8 plane crashed twice in the last year, and now all of them are grounded. That'd be like Tesla saying, well, we can't sell any more Model 3s. They're done. That can absolutely bury a company. So when you get into airspace, there's a lot more scrutiny. So these drones have to go through a very lengthy process of getting certified and getting government officials to stamp out and say, yes, it's okay if we fly above people. And Amazon is very far away from that, and Google's also in this space. There's a number of other competitors. The advantage that we have over them, what I want to kind of do right now is just draw a very simple network. We fly from point to point. When you fly from point to point versus flying wherever you want, this would be an Amazon. They've got a central hub and they're going into your backyard. That means there's thousands, millions of possibilities of where they could fly. It's a lot harder to dictate, what are the wind speed effects going to be? What am I going to be flying over? Is there some airport here or something like that they're unaware of? There's a lot more that you have to think about when your range is limitless. For us, because we're flying from one point to another always, we can actually go in and look at that entire route and say, hey, here are areas we need to avoid. Here are things that we need to do for this particular route. It's a distributed network versus a centralized network. The other beauty of something like this is, say if we put a network all the way over here, lights? Sure. A little easier to see. With a network with multiple stations, this could be all of a sudden 200 kilometers away, and we're able to hop from point to point to point and reload our batteries at each stop to actually effectively increase our range. You only have one single kind of primary hub. Your range is limited to where that hub is located and the capabilities of your vehicle. Yeah.
How does air traffic work?
Air traffic. That's actually pretty simple. So there are maps out there. You can actually go on and look at them right now, and they'll actually show you where every single airplane is above us, and they will show you different zones. So we're actually probably pretty close to Class B airspace. I'd have to look at the map, but the closer you are to certain areas, you're in a different zone. So if you're close to an airport, there's a big zone around that basically says, hey, within this distance, you can't fly at all. A little further away, a quarter mile, you have to be within certain elevations, and so on and so forth. So there's different regulations for different zones, and they're all already out there. So it's just a question of us taking that information and piping it into our system so that we know when we plan our routes, we can see exactly which airspaces to avoid and which ones are safe for us to go. Yeah.
Do the drones have like a navigation system, or they just communicate with the hub and go across?
They do. They have multiple navigation systems that are redundant. Who can tell me the importance of having redundant everything in a drone? What was it? Serve as a backup. Yeah, because say, what if one of these motors dies? You don't want the thing to crash. You need to be able to still fly. If a navigation system goes out, so we have 2 GPSs, we have 2 magnetometers, we have 2 cellular modems. I mean, we have everything is redundant within the vehicle, so that on the occasion that something fails, everything will still keep functioning. That's very important for what we do.
What does happen
If a motor fails on this, we would automatically trigger a failure scenario, and there's a parachute that would fly out of this drone and deploy. So we would say, it's not safe to fly anymore. Now, we have a couple versions of our vehicle, and one of them actually has, instead of just 4 rotors, which would be a quadcopter, which is what we primarily fly, we also have X8s. And X8s just mean there's 2 motors on each arm. So in that case, again, you're even more redundant. So if you lost 4 motors on an X8, as long as they were at the different corners, you'd be fine. There's actually some cool research out there as well. It's a little bit too young for us to start incorporating into our work, but there are some cool startups and universities out there that have started to incorporate machine learning in doing things like killing off 1-2 motors and having the drone be able to compensate and fly off of only 3, sometimes 2 motors. So there's some cool stuff out there that hopefully eventually will start getting incorporated into industrial applications like this. Yeah.
Can you speak
Here,
up?
hold on.
Like the drone doesn't, like if the parachute deploys, the drone doesn't aim.
It can, definitely. So,
Repeat the question. We can
yeah. So the question was, what happens if a parachute deploys and it lands in a road? Let me raise you to that. What happens if a parachute deploys, you've got a vehicle falling out of the sky, this thing weighs about 40 pounds. What happens if that 40-pound weight comes out of the sky and hits you in the head? So that's what we actually engineer around. So there's a data point, I'm not going to have the number right off the top of my head, there's a certain level for the amount of energy in joules that it would take to kill you. So we engineer to be well below that level. So the size of the parachute dictates how much energy we're going to have to dissipate before it hits the ground. So that thing actually comes in very gently. You would feel it and you'd be like, hey, what the hell? But you would be fine. If we put a smaller parachute on that, it'd be like a rocket coming out of the sky and it would go crash. Now there have been a few rare instances where a parachute deploys and it doesn't work. So we've spent thousands of hours. We have a farm, we rent farmland out in Pescadero where we actually do a lot of flight testing, and we have deployed parachutes, 5,000 times to make sure that we have the right formula as far as how do you pack this parachute, how do you attach it, how do you make sure that it actually comes out and unfurls and actually lands properly. So we've put a ton of testing into that to make sure that those instances would never happen during our regular operations.
You said you were launching in like Switzerland and stuff like that?
Yeah.
I know that it hails and gets pretty heavy storms there.
Yeah.
How would the parachute like work in those scenarios, like reliably?
So, going back to his question, do we fly in rain? The answer is yes. The answer is we don't fly in all rain. So there is a threshold for how much it's raining, how much it's snowing. So if it's an absolute blizzard, we would not be in operations. The threshold, again, I'm not going to know off the top of my head, but there is a limit at which we say, hey, yes, the parachute would not work in these conditions. It's raining too hard. The reality is it takes a lot of rain to stop the parachute from working. Think of it as, this massive object coming down. That thing's going to be totally unfurled. A couple raindrops really aren't going to have much of an effect. Hail, that would probably be a different story because you might be able to start damaging the parachute itself. And if you damage the parachute and it starts ripping, that could lead to some issues. But that, again, takes a lot of force. Other questions? On drones? Yeah?
What are you going back to school for?
What am I going back to school for? Great question. So I actually, having spent 5 years now as a mechanical engineer, have realized I think I want to try and do something different. So I'm going back to school to focus on what my minor was in, which is industrial engineering and operations research. So one of the things I've learned here, I mentioned hospitals and airports, same thing with drone networks. We have to have a very sophisticated network, and it's all about optimizing where we put those networks, how fast we can fly in between them, and a lot of that takes into consideration is the data science behind it. So I'm going to go back to UC Berkeley again and get a master's of Engineering and Industrial Operations and Research, and that will be focused on data science, machine learning. So I'm going to be much more on the digital side of things, probably moving forward. It's exciting. I always love working with my hands. I think there's a beauty to that. But if I'm anything like any of you, I'm kind of never satisfied unless I'm learning. So kind of when you start to plateau in a certain career, you feel like it's time to switch gears.
Awesome. Any other questions? One more question?
You said about replace battery. So I know there are certain this kind of field of drones or helicopters, mainly designed field that has different strategy or method to recharge. Some even like use cross support to charge with the power line. But I don't know if what does your set view with regarding the recharge battery? Does it needs to remain intervention?
A couple parts of the question. Did everyone hear it?
No.
Okay. To repeat the question and correct me, you can pipe in as well. The question was based around how do we recharge the batteries? There are other companies out there that use things like, and I haven't heard of this, which is interesting. Basically, connecting to existing power lines as they're flying or recharging.
Actually, it sits on the power line.
Sits on the power line and charges directly from the power line, so it can increase its range. To dive even deeper into that, there are so many different types of drones. Go back 10 years and drone was a dirty word because it was only really used by the military, and it's this big, massive thing that's miles up in the sky and spies on people and shoots predator missiles and things like that. And those would run off of a, gas engine. Very different shape. It has wings. It looks like an airplane. Quadcopters are very different. You're starting to see a lot of companies focusing on what we call VTOLs, vertical takeoff. Oh man, I just forgot.
Vertical takeoff and landing.
Yeah.
Vertical takeoff or landing? What was it, the O?
Vertical takeoff.
The O stands for something. Who's got the O?
It's just take
Bonus points.
Takeoff is TVT.
Yeah, take off.
Oh, okay, great, perfect. Vertical takeoff and landing, but then when it's in flight, it actually positions forward. And so you can have wings on it then, and you can switch motors. You could have quadcopter with 4 motors to go up and down, and then as soon as it's positioned and flying forward with a couple wings for better aerodynamics, you can have a couple smaller motors on the wings. If you guys look at the old Amazon Prime, the new Amazon Prime drones, the Google Wing drones, a lot of them have kind of that capability. So that's one way to increase range. There's companies out there doing hybrid motors, so they're using hydrogen cell technology and other things to all of a sudden run mini gas generators and get massively further ranges. The beauty of our solution at the moment, and although we'll probably go in a direction similar to that eventually, by having more stations, we increase our capability to interact with customers. And we also increase our range. So there's no need for us, and there's a sweet spot. You could take a drone this size and you could add 3 times as many batteries onto it, but batteries are heavy. So when you do that, you don't actually increase your range. There's a sweet spot of having the right amount of battery to the whole vehicle weight to increase your efficiency. So it's better for us to just add more stations and add our capability to interact with customers at existing points, as well as increase the range that we're able to fly. But definitely adding in technology as far as being able to fly further with wings or some sort of, assisted flight mechanics is a good way to go as well. There's a question somewhere over here? Yeah.
So, how easy is it to implement more stations? Because are you doing it in public, sort of federal land, and what's the regulations on that?
It's almost entirely private. So, yeah, everything that we do currently is within hospital networks. What you guys don't really realize is take somewhere like the Bay Area right here. You can throw a stone and hit a hospital in almost any direction. So there's a very distributed network that already exists. Another great application for where we will be implementing in the next year is big campuses, industrial campuses. Take somewhere like Boeing. They have huge plots of land with factories all around and offices, and all of a sudden, rather than taking golf carts and moving objects back and forth, you set up a number of stations on a campus. It could even be a school campus, and you start moving goods in that way instead.
So, manufacturing-wise, is it in mass produced or is it hand by hand for each station we're growing right now?
Yeah, great question. So the scale that we currently produce at is we manufacture typically about 10 drones at a time, and that takes about a month. So we make relatively small batches, and then the station is basically one-offs. So we're going to produce 4 of them in the next few months, and that's going to be our first kind of trial run. We're too small of a company to then go and manufacture them at scale. So what we will actually do is we'll work with a contract manufacturer. So we'll actually basically have another company who has a huge factory, tons of space, and we'll give them all the documentation and just say, hey, we're going to pay you $50,000 to build out every single one of these. And so we'll make a contract with somebody else. Yeah.
Does your company plan to have your own machine shop in the future to manufacture yourself, or do you want to keep outsourcing?
That's a tough question. It really depends on the resources that you have available. Right now, with a small company of 70 people, of which there's only 30 engineers, we don't have the time or the energy to do that when we can pay somebody else to do it. Depends. If you start getting into larger scales, sometimes, it becomes an economics question, which is what industrial engineering is about. How much does it cost me to outsource this and have somebody else do it versus put in the huge upfront cost of buying a massive factory and all the machines it takes and making them ourselves? Because it's cheaper to do it that way, but it takes a lot of capital upfront. So it really, there's a break-even point. And once your scale reaches a point where you're making enough of them, it does make sense to start producing yourself. I think we're a few years away from that, though. You have a question? Yeah.
How will an expansion of drone technology further impact society and the laws within it?
Oh man, it's totally going to mess everything up. If I'm being perfectly honest, when I go to a park or you're outdoors somewhere and all of a sudden you hear this buzzing, it's kind of annoying. There's a societal implication right there as far as, can you guys imagine if every time you wanted to get your Chipotle burrito or whatever it is, a drone's going to fly over your school and drop it off? There'd be drones flying all over us all the time. It'd be annoying as hell. There's going to have to be a lot of regulations that go into place to control who can fly, when, and where. The purpose of doing something like drones and using them for certain applications is also because of societal implications. Something we've considered, we haven't gotten into yet. There are a few companies doing it, but companies are taking drones and using them to deploy AEDs when somebody has a heart attack. They're using them to deploy first aid kits in emergency situations. They're using them in disaster relief zones to bring medicine and aid to people who don't have road access. That was a founding point of our company. We've moved slightly away from that. We're still in the healthcare space. But there's massive, opportunities to actually have a positive impact on society, but we also have to be very cognizant of the problems that could come with it. So eventually, I think this will take a little time, there's going to have to be a lot of research that goes into how can we make the propellers silent? How can we start doing things? There will be basically highways designated in the sky that say, okay, these are the zones that everyone's going to be flying on, and it's going to be lanes in each direction. And there's going to be a lot that has to go into it. If any of you guys are familiar with, one of the big things also in our space is the transportation of humans. So Uber is putting tons of money and a lot of other companies into how can we basically create flying taxis. So they just kicked off Uber helicopter actually in New York. So you can actually go and pay $220, and rather than be a peasant and get driven around in a vehicle, you can go and they put you in a helicopter and fly you to where you want to go. That's happening this July. It's happening. That's going to come up very quickly, and the reason behind that, a lot of people talk about autonomous cars. The problem there is if you look at our highways right now, there is so much existing infrastructure. There's so many of us who are out there driving normal vehicles that don't react the same as a computer-driven vehicle would. So there's a lot of work that has to go into putting in those regulations and easing that transition. Yeah, 10 years from now, the majority will be self-driving cars, but there's going to be a lot of work that goes into getting there. When you look up in the skies, there's a lot less going on, so it's a lot easier to start dictating what those regulations can be. 1 minute? Okay, one more question.
Wait, Sophie, you had
Take one or two more, depending on how.
Is the government supporting sort of this change towards autonomous cars/drones, or are they more?
Drones? Yes. Yeah. So up until a couple years ago, there was absolutely no support almost. It was actually blackballed for us to work within the United States. All drone companies. So that's why when you actually look at a lot of the development work going on, our first networks were in Switzerland because the Swiss government was more open to working with us. Google does a lot of their testing down in Australia. Everyone is kind of more internationally based, and we're now, just this last year, all getting waivers to say, okay, you can start operating here. So they are, yes, being supportive.
So to his question, if you actually release a new drone, how long would it take to get it approved?
To get it approved? It's about a 3 to 6 month process. Yeah. And I'm not too familiar with that. I do a lot of the back end work as far as making sure that in my design, these systems are redundant and being able to prove it and show those hours of testing, thousands of hours that we put into the failure system, that the parachute works, all these things, all that gets documented. And then we pass it off, and we have a separate kind of legal team that works directly with the FAA to go through and say, yeah, okay, this all makes sense, and you guys have thought out all the different scenarios, and then they get the stamp. But it's a lengthy process. Cool. Well, thank you guys for listening to me. I will